Okay, good morning once again. We are on to the next segment of our classes for grade 8, and we'll be looking at something called angles in a polygon. It's an aspect that concerns itself with geometry. And when we mention a polygon, what comes to our hearts? Essentially, a polygon will suggest a shape, a type of plane shape. A plane shape with at least 3 straight sides. And we mentioned these certain shapes come to mind. We imagine a triangle, which is the lowest member of this family. Then we have the quadrilaterals, the next level. Then to the pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, and decagon 10. We'll stop there, and it's a large family as depending on how much our brains or our processors can handle. Now, a quick reminder here that our textbooks of reference will be Essential Mathematics for JS2 and our New General Mathematics for JS2. These are the books we use to run our experience here in London. Okay? Before we go into the topic proper, I think it's important for us to draw from previous knowledge. To understand angles in a polygon, we would expect that you already know things like what it means to have vertically opposite angles, angles on a straight line, corresponding angles, conjugate angles, types of angles as the case may be. But I won't bore myself or bore you by going into all these technical details because I have done a very comprehensive video on this, and I advise you to look up my channel to watch this video. While uploading this video, I will try as much as possible to attach the link for the introductory aspect of this video so that when you start watching this video, you'll be able to flow with what is done. Having said that, let's have a little recap on what we need to know before coming into angles in a polygon. Okay, so we have 2 questions on the board. We have question number 1, testing a concept, and we have question number 2, testing a whole lot of concepts. So I'll try to guide us by trying to solve them. Let's look at A, for instance. Question A. We know from our elementary knowledge of formal geometry that angles on a straight line is what? 180 degrees. So what that will mean is that A plus 130 will be equal to 180 degrees. Now, it's important at this level to state the reason. One thing interesting about formal geometry is that for every argument you put forward, you must state the reason. I'll take that down so we can have more space to work. And what is the reason? Angles in a straight line. I'll write them out in full, but as we proceed in the course, I will begin to introduce you to shorthand. There are shorthand ways of writing this thing, and it's important that we get used to these things as early as possible. So from your notice, we started with trying to state an equation, and now we need to find out what that will be. If A plus 130 gives me 180, it means that 180 minus 130 is what I am looking for, which will give me what? 50 degrees. Interesting, that's good. Now we go to B. Now B talks about parallel lines being cut by a transversal. And remember that if you have a pair of parallel lines being cut by a transversal, you begin to have interesting properties coming up. But before we go to the parallel lines, we can actually find M, N, and L. Now, by observation, you discover that N is equal to 57 degrees. N is equal to 57 degrees. And the reason for that is what? Vertically opposite angles. Please, I'm writing like this because of the space allowed me here. You're expected to write everything out in full. Now, with that done, I can say that M plus 57 degrees will be equal to 180 degrees. And what's the reason for that? Angles in a straight line. And with that said, I will have that m, if m plus 57 gives me 180, it invariably means that 180 minus 57 is what I'm looking for. Now, the catch here to remember is this. The inverse of addition is subtraction. So if you are not adding, you are subtracting. If you are not multiplying, you are dividing. So that's what you must keep in mind when dealing with these concepts. So this will give me 123 degrees. And from here, we'll discover that L is equal to N. The reason is what? Vertically opposite angles. Good feedback. Shows you know these things very well. Vertically opposite angles. Right? So with that said, we're going to have that L will be equal to what? 123 degrees. So we've been able to map out all of these angles. And with all of these angles in place, we can now find this. Because this line is parallel to this line being parallel to this line, we can safely say that a new set of properties are coming up here. We have three of them. We have what is called corresponding angles, alternate angles, and what? Allied angles or co-interior angles. Now, this is why essential mathematics is such a good textbook and the bomb. In essential mathematics, a lot of these ideas are well treated. They're well treated. So if you grab a copy of this book, some of these concepts will get used to them. Alright, so we're going to use, let me add at this point to say that there is no one particular way in formal geometry. Formal geometry somehow is tied to IQ, what you can see. What is IQ? What you can see. IQ is what? What you can see. I don't want us to get scared with a regular definition of IQ. IQ involves what you can see. So, the way I will solve it may not necessarily be the way you will solve it in an exam setting. So, but what's most important is that no matter the branch you're taking, just like imagine what was done in the Loki series, the branching of the multiverse, that's the same kind of feel you have when you're talking about this. You can take different directions and still come up with the same answer. Alright, so with that said, we can say that P, I want to be deliberate to test all the, to try out all the rules. P plus 57 is equal to 180 degrees. What is the reason? Allied angles. Allied angles, or what is called co-interior. If this line is parallel to this line, it means that this angle here and this angle here will sum up to what? 180 degrees. In my other video, you get to see that I explained all of these concepts in detail. So P will now be equal to what? 180 minus what? 57, and that will be what? 123 degrees. Okay, that takes care of that. Now, we can also say that P, I said I want to test all of them, I want to try everything. P is equal to N, or rather M. Okay, let's say P, fine. P is equal to M. P is equal to N. They are corresponding. Please take note that these rules only work when the lines are parallel. That's the condition, minimum condition for these rules to work. Now, I want to now be deliberate. I want to see if I can use corresponding. So I can say that J is equal to 57 degrees. Now I'm deliberate. I want to test all of them. In the exam, you can use anything you want to use, provided it's logically intact. Now, this will be what? Alternate. Look at it. J is equal to 57. Alternate. There's a word I use for that. Let's see if I can. Z angles. Okay, fine. Z angles. Okay, that's a new one. I think I will learn that. I was thinking of something different, but we call them. Okay, I think I'll take that name. Z angles. So, just like my students are teaching me here now, We call it the Z angles. So if you watch, look at this. It's the Z angles. Good. I think I like that. So alternate angles. Okay, so now we are left with what? K, is that not? So we can say K is equal to P. Oh, I didn't conclude this. That means this will be equal to what? M is what? 123 degrees. So sorry about that. I didn't conclude that. So this will be equal to what? 123 degrees. And what's the reason for that? Vertically opposite angles. Right, so I think we have one more left to go. Q. So I can say Q is equal to J. What is J? So that is vertically opposite angles too. And with that, I'll have that this is equal to 57 degrees. So the feedback I've gotten from this is quite encouraging and gives me courage to go into angles in a polygon.